actually today I'm honored to introduce you guys my first presenter for my cohort, Hugh Sullivan, great student, hardworking. And actually today he's going to talk to us about roles of carbohydrates, protein, and amino acids for athletic performance and recovery. And he's a master's student of kinesiology with concentration of nutrition. So Hugh, go ahead.
Good morning, everyone. My name is Hugh Sullivan, and I'm going to do my presentation on the roles of carbohydrates and protein and amino acids on athletic performance and recovery. We all know that nutrition is important, but we all know that nutrition is important, but the way we time our nutrient intake can make a big difference on our training outcomes. The goal of this presentation is to break down the best strategies for carbohydrates, protein, and amino acids supplementation so that athletes can maximize their performance and recovery. All right. For the introduction, when it comes to athletic training, timing is everything, and that includes nutrition. The pathway of adaptation model explains how what we eat and when we eat it influences muscle recovery and performance. We can divide nutrient timing into 3 phases. One would be pre-exercise, what we eat before training, fuels our workout and can help delay fatigue. And intra-exercise, for longer workouts, carbs or amino acids help sustain energy levels. 3, post-exercise, after training, refueling with the right nutrients speeds up recovery and muscle repair. A big part of this process involves insulin and cortisol, 2 hormones that affect muscle adaptation. Insulin is like a growth switch for muscles, helping to store nutrients, while cortisol is a stress hormone that in excess can lead to muscle breakdown. Managing these properly is key for optimal recovery. Let's talk about carbs, because whether you're a strength athlete or an endurance athlete, carbohydrates are your main fuel source. For strength athletes, like weightlifters and sprinters, short explosive movements rely on glycogen, which is stored in the muscles. After an intense workout, your glycogen stores are depleted, so refueling with 1 to 1.2 grams per kilogram of body weight of carbs can help replenish those glycogen stores. For endurance athletes like marathon runners, they have a different need. Their bodies require a steady supply of carbs over time, meaning they provide both pre- and intra-exercise carb intake to maintain energy levels. Without proper carb intake, athletes can hit a wall, literally, where fatigue kicks in and performance drops. So timing your carb intake based on the sport is very crucial. I was a slide ahead, or I was a slide behind. Protein and amino acids. Next up, protein and amino acids. These are the building blocks of muscle recovery and growth. For strength and power athletes, research suggests that consuming 1.6 to 2 grams per kilogram of body weight per day is ideal for maximizing muscle gains. For strength, amino acids play a special role here. We have branched-chain amino acids, which can help reduce muscle breakdown and fatigue. And we have essential amino acids, which are critical for stimulating muscle protein synthesis. One common debate is whey protein versus plant-based proteins. Whey is fat digesting and rich in leucine, which is key for muscle growth. But plant-based proteins, when properly combined, can be just as effective. At the end of the day, the best protein source is the one that fits an athlete's goals, dietary preferences, and digestion tolerance. Now let's talk about personalized nutrition. The idea that every athlete should follow the same diet is outdated. Metabolic profiling is helping athletes optimize their nutrition based on their unique needs. For example, gender differences play a role. Female athletes may metabolize carbs and protein differently than males. Sport-specific demands matter. A powerlifter and a marathon runner should not have the same macronutrient distribution, genetics and gut microbiome research are showing that people respond differently to the same foods. By tailoring nutrition plans based on these factors, we can maximize performance and recovery for each individual athlete. Future research and innovations. Looking ahead, the future of sports nutrition is getting interesting. We have AI-driven meal planning, which is becoming more common, helping athletes plan their diets with more precision. Research on BCAAs and EAAs is continuing to determine which is better for long-term muscle retention. The gut microbiome is an emerging area of research. Scientists are discovering how the bacteria in our gut influences digestion, recovery, and performance. As technology and research evolve, we'll be able to personalize nutrition like never before. And to summarize everything up, 1, carbohydrates are the primary energy source, but different athletes have different needs for them. 2, protein and amino acids are critical for muscle recovery and growth with specific requirements based on training goals. 3, personalized nutrition strategies will continue to shape the future of sports performance. The more we learn about nutrient timing, metabolic profiling, and supplementation, the better we can help athletes optimize their performance and recovery. And those are my references for all the information you saw above. And these are just some questions to think about or ask me by the end of this presentation. How do carbohydrate needs differ between endurance and strength athletes? Is whey protein superior to plant-based protein for recovery? What are the latest findings on amino acid supplementation? And most importantly, how can we continue to optimize sports nutrition through personalized approaches? Thank you all for your time. I would look forward to questions and discussion.
Any questions? Okay. Well, if not, a round of applause for